So at this point, the expression for controlling the number of points on each of our line is really starting to take shape. The artist has a lot of control. The artist can go in and specify a maximum number of characters that can be copied to any given bench, and we're not going to go above that. That's excellent. We know that the minimum value will be only one character being copied to a bench, but an artist can check a toggle, and with that toggle he can specify that empty seats can exist, and so now we can have empty seats show up, which is really cool. So, I mean, we have a lot of control. The artist can even adjust a seed so that he can find the distribution of characters that he's pleased with. But what about this bunching problem? We have it right now so that we're not taking any type of fall off into account. If this back seat can have 5 characters on it, that means the front seat can have 5 characters on it. And that's really bad. We need to come up with something in our expression that allows an artist to control a fall off so that, hey, I didn't actually mean to do that. Let's just undo that there. That allows an artist to control a fall off so that by the end of the rows, we can have that maximum number, but based on a parameter that the artist sets, we'll have a smaller number at the front. So let's go ahead and jump over to the whiteboard and spend just a few minutes talking about how we would set this up, and then we'll do it, because in the end, it's actually quite simple. So I'm going to pull up a new slate real quick, and let me start out by drawing a simple top-down view of 5 rows. So 1, 2, 3, 4, 5. So we know that the artist has set the rows to 5. Let's go ahead and say that our maximum balls that can be placed on here are, let's say, 6. So you could have 6 down here, 6, 6, 6, 6, okay, placed on any of these rows. Now let's think about this. When an artist is looking at the stadium and he's adjusting the number of characters that can be on each bench, he's going to see a lot of large benches. So he's going to adjust for that. He's not going to spend most of his time looking at these bottom ones. But what happens is, as he gets a nice looking distribution back here, these guys are really cramped. So that is what we need to fix. We don't need our characters intersecting with one another. So how do we fix this? Simple. We know the maximum bleachers per row, or we called it per bench, didn't we? Yeah, per bench.
Yeah, balls per bench.
Yeah, maximum balls, per bench.
Because bleachers per bench would be kind of funny.
Yes, it is. And just so that our audience knows, it's also getting very late right now, so
yeah.
I'll do my best to prevent any slip-ups, but I know Steve's got my back. So with this number, let's say that we've set it to 6. Well, if we were to multiply this by some number that started out really small and increment it all the way up to a value of 1. Oh, you got to love when that thing jumps. Let me undo that real quick because that looked kind of bad. There we go. So increment it all the way up to a value of 1. Then we would have some small number. Let's say that we set up a number that would allow just 1. But when we multiplied our maximum balls per bench up to, or by 1, in this case, we would have had 6. So if we set the follow-up for it, we could have only 1 show up on the first row, maybe 2 on the next, 3, then 4, so on and so forth. So how do we set that up? Well, looking at this, this means I need some sort of small number to a large number that I can then turn around and multiply with my maximum balls per bench somehow in that expression so that I can affect that number. So let's start looking at what information we know that we have. Well, we know that we have our total number of rows. We've got 5 rows. We can also tell what row we're on. So row 0, row 1, row 2, row 3, and row 4, since everything is 0 based. So we need to come up with something that will generate a number that goes from some small, I'll just do a little squiggly, some small number all the way up to a value of 1. Very simple. What if we were to do row number, let me find a place to write this. So our row number over our rows. Well, this won't climb all the way up to 1 because it is not 1 based, it's 0 based. So we would end up with our largest number right here, 4. This guy would end up, that row would end up with a representation of 4 over 5. Row number 4 over a total of 5 rows. We're very close to 1, but not all the way. We need 5 over 5. We can easily offset for this by adding 1 to our row number. If we add 1 to our row number, don't we end up with, let me see, how do I want to draw this? We end up with 1 over 5. We end up with 2 over 5, 3 over 5, 4 over 5, and finally 5 over 5. So this goes from a very small number all the way up to a value of 1. Okay, so that is what we are looking for here. So how do we take this and turn it into a controllable range between 0 and 1? Because this is not giving us a controllable range. This is giving us, what is it, 0.2? All the way up to a value of 1.
Exactly, and that's going to be hard-coded. We have no control over that.
Right, but we want to give the artist control,
exactly,
as we've been doing with everything we've been setting up with this project. So we're going to add a new custom parameter up onto our asset itself, and that will be our bias falloff. All right, that's a lot to type. So this shall now be deemed on the whiteboard as our BF. All right, so bias falloff. Now, we know that with our bias falloff, it's going to be some sort of number, some sort of small number that's going to cap out at a value of 1, because we don't want an n number that's going to be larger than 1. So we'll let the artist control with 0.001 up to 1, something like that. And let me use some sort of example, like what if we only wanted to remove 30%? It's like 0.7 or something. Take a look at this. There is an expression. Well, first of all, if I did go with something like 0.7, that means that I would be looking for 0.7 and have that go all the way up to 1. So if I did 0.6, this would need to be 0.6 all the way up for 1. But everybody along the way needs to be properly distributed so that we go from 0.6 up to 1. Okay, so everything's changing up to that value of 1. How can we remap 0.2 to 1, or whatever the number is, of course, because it's based off of row number and all that, our small number to the value of 1 to a controlled value up to 1? Very simple. There is an expression that we can use called fit01. Fit01 means this is going to remap a value coming in that we know is between 0 and 1. Okay, well, we have something that's between 0 and 1. This guy right here, let's just say that he is A. So he's equal to A. So if I was to put that expression in here, so row number plus 1 over rows, if I was to put that as my first parameter, and then my second parameter, put my bias falloff, this is my remapping now. So there's my bias falloff going up to a value of 1. So all this does, the fit expression says, take our value as we're going through here and remap the range between low, high. That's going to give us exactly what we want. If we now take the result of this and we multiply it somehow by what's being calculated in our expression up above, we have now said that our maximum balls per bench is a smaller number down here, maybe 1, maybe 2, still maybe not enough to go over 2, then 3, then 4. But their last one will always be the true maximum number of balls set up by the artist. Okay, so where are we going to put that in? Well, if you recall, we have the floor portion of the expression, and in the floor portion of the expression, we had our maximum balls per bench in there, and we had added to that our toggle, and then we just multiplied that by the random. Well, we could just go ahead and multiply that by this fit expression right here. So let's say this whole thing is equal to B. So we just put B in here. So we basically our maximum balls per bench plus toggle multiplied by our fit01 of A, the bias fall off, and 1, and then multiply that by the random that we had put together. And I'm just going to put rand and blah because everybody remembers what it is. And then we close that guy off. Close that guy off. That right there gives us the correct numbers we're looking for so that we do not have a case where we have characters that are intersecting right here. This allows an artist to nicely distribute a crowd on the back and not worry about a bunching problem occurring down here because everything falls off as we work our way down. And that's good stuff. So that's pretty much everything I want to show here. Steve, is there anything that you'd like to add to this?
No, I think you covered it fantastically.
Okay, well, thank you. So with that, we'll go ahead and jump over to Houdini and put it all together.
Great. So I'm going to jump over to Houdini, and the first thing I'm going to do is create that bias fall-off parameter.
Okay.
And then from there, we're just going to simply modify our points expression.
Sounds great.
So I'm going to right-click on our asset and come down to Type Properties. And from the Type Properties, let's create a new float parameter under our audience folder. And this parameter is going to be our bias fall-off. Bias fall-off. And we've already said we don't want this guy to go larger than 1. We also don't want this guy to go smaller than 0.
Yeah.
Because we don't want less than 0 times our maximum balls per bleachers, because otherwise...
multiplying all that through and we'll end up with 0.
Exactly. So 0 makes sense to be the minimum. 1, obviously, because we don't want to have more than our maximum for our upper limit. So I've locked it between 0 and 1.
Did you say you want to let it actually hit 0 since we're multiplying it by that?
I guess we'd really want it to be slightly larger
slightly
than
above 0, just to prevent anything.
Let's make it 0.001.
That's perfect. Okay.
Cool. And then let's jump up and find our template line. Now we could jump in and just change the points expression directly. To simplify things a little bit, I'm going to create a new parameter to create our bias value. By our bias value, I mean this guy here, the fit expression, B.
Okay.
I'm going to create that as a new parameter, and then I'm going to multiply B in with our existing expression. Actually, just as we've done here on the whiteboard, which works out really nice.
Very nice.
So we're going to take the fit01 of our row num plus 1 over rows between our bias fall off and 1, and we're going to have that as a parameter. And then we're going to reference in our points parameter this new parameter we created and multiply that by our maximum balls per bench plus our toggle and also by our rand.
Okay.
So let's create the new parameter. So I'm going to right click on our audience template line and come up to edit parameter interface. We're going to be dealing with a float parameter, so we'll create a new float, and I'm simply going to name this to bias and accept out this dialog. And for the bias parameter, let's bring up the expression editor, and I will make that full screen. We're going to take fit01. Well, what was the value we want to remap? Is our row number plus 1 over our number of rows. How do we get our row number? That's a stamped parameter back from our copy benches for rows copy sop.
Okay.
So we're going to use a stamp, and we're going to grab our stamp from the copy benches for rows, and the parameter name was row number. And we'll default that to 0, so that's our row number. We do want to add 1 to that, and we want to take all of this and divide that by our total number of rows, which is the rows parameter up on our asset. So we're going to take that value and we're going to remap it between our new minimum, which was our bias fall off, and a maximum of 1. So let's grab our bias fall off. Is our new minimum, and our new max is going to be a value of 1, and with that we've closed off our fit01 expression. So I'm going to accept that. And then over here in our points expression, we can simply take our max balls per bench plus our toggle, and where we multiply it by our rand, we can simply multiply in our bias. So let's reference that bias parameter we created here on the line sop. So our channel bias, and with that, if we accept, fantastic, and then bring up our bias fall off. Okay, so it looks like something in our expression's not quite working right, because all of these guys are falling off at the same rate. I'm thinking that means our row number somehow isn't getting stamped properly, because we're not getting a unique number for all of these guys. So let's take a look over at our bias.
So you've got a typo in there.
Probably. I've already seen it on the pop-up. Row number, we name that guy row num.
Yep, that's right.
If we enter that to accept that, bring back our parameters. Much nicer. So now as we fall off, we're falling off from the back towards the front, and we can see this much more clearly if we boost this really high. So no fall off, and as we bring the fall off in, less and less points
you'll
towards
notice
the
more
front.
towards the front, less and less balls.
Very nice. So yeah, with that was everything that we were going to cover in this video.
Outstanding. I believe in the next video we're going to be offsetting our lines, but that has nothing to do with the number of points. So that's pretty much going to wrap up the points expression that we've been working on in the last few videos. I hope everything's been clear. We've tried to make it as clear as possible. So with that, that's going to wrap up this video. Thanks a lot.